Hey everyone, welcome back to another lesson in MCV4U. Today we'll be looking at the intersection between a line and a plane. And so here, when we look at the intersection between a line and a plane, again, the question arises, what are the possible ways that a line and a plane in three dimensions can intersect? The first possibility is that it intersects, again, only at one point. The second possibility is that there is no intersection. And then the third possibility is that there's infinite intersection, which means that the line lies on the plane. So again, you can either have zero solutions, one solution if the line is parallel to the plane, and then it could have infinite solutions if the line lies directly on the plane. And so here we see that to determine the type of intersection that occurs between a line and a plane, substitute the parametric equations of the line into the equation of the plane. So here, example number one says to find the intersection of a line with parametric equation x is equal to 1 plus 2t, y is equal to -6 plus 3t, and z is equal to -5 plus 2t, where t is an element of real numbers. And the plane whose scalar equation is 4x minus 2y plus z minus 19 is equal to 0. And so here, if we sub, again, our parametric equations into the equation of the plane, we'll get 4, 1 plus 2t minus 2 times -6 plus the 3t plus -5 plus 2t minus 19 is equal to 0. And here, we see that 1 plus 2t would be our x value. -6 plus 3t is our y. And -5 plus 2t is z. So here, if we expand this out, we get 4 plus 8t plus 12 minus 6t minus 5 plus 2t minus 19 is equal to 0. And so here, if we're solving for t in terms of, again, these values, here we can see that we have all these put together. So we can collect our like terms. So we have 8t, -6t, and positive 2t. And then in terms of our coefficients, we have 4, 12, -5, and -19. And so here we will get 4t minus 8 is equal to 0. And here, therefore, t will be equal to 2. And so here we see that t is equal to 2. So if we sub those back into our equations, that will give us our point of intersection, or our POI. So here, x is equal to 1 plus 2 times t, which is 2 here. So x will be equal to 5. Here for y, we get -6 plus 3 times t, which is 2 here. So here y is equal to 0. And finally, for z, we get -5 plus 2t. Here t is 2. And so z is equal to -1. And so here, our point of intersection will therefore be 5, 0, and -1. Okay, example number two says find the intersection of the line and x minus 2 over 3 is equal to y plus 5 over 1 is equal to z minus 6 over 8. And the plane I, 5x plus y minus 2z plus 2 is equal to 0. Okay, so here we can write our equations. So here we see that x will be equal to 2 plus 3t. Y will be equal to negative 5 plus t. And z will be equal to 6 plus 8t. And so here we can sub these into our plane equation. So here we get 5 times 2 plus 3t minus t minus 2 times 6 plus 8t plus 2 is equal to 0. So if we expand this, we get 10 plus 15t minus 5 plus t minus 12 minus 16t plus 2 is equal to 0. So here we can simplify a few things. Here we have our 10, negative 12, and positive 2. Those will cancel each other out. Here we have our collector-like terms. We have 15t, t, and negative 16t. And here, again, we're left with our negative 5 as well. So here, what we see is we get 0t minus 5 is equal to 0. And here, what that means is, again, that there's no solutions for t, which therefore means no point of intersection. Okay, example number 3. Here says, find the intersection of the line x minus 2 over 1 is equal to y plus 1 over negative 2 is equal to negative 3 minus z over 5. And the plane I, which is 3x plus 19y minus 7z minus 8 is equal to 0. So here, again, our equations, we get x is equal to 2 plus t. We get y is equal to negative 1 minus 2t. And here we get z is equal to negative 3 minus 5t. And again, we'll take those, sub those into our equation of our plane. So here we'll get 3 times 2 plus t plus 19 negative 1 minus 2t minus 7 negative 3 minus 5t minus 8 is equal to 0. So here if we expand it, we'll get 6 plus 3t minus 19 minus 38t plus 21 plus 35t minus 8 is equal to 0. So here, and we have 3t, negative 38t, and positive 35t. Those will cancel out. And here we have 6, negative 19, positive 21, and negative 8. Those will also cancel out. So here we get our answer. We get 0t plus 0 is equal to 0. And what that means is that there are infinite solutions for t. And again, that would mean that there are infinite POI. Again, which means that here the line lies on the plane. Here, so it says determine the point of intersection of x is equal to -3 plus 3t, y is equal to 4 plus 8t, and z is equal to -5 plus 7t. Here, t is an element of real numbers, and the x, z plane. Okay, so here we're assuming that there is a point of intersection. Okay, so here if we look at our xz plane, again, when we have an xz plane, all points will be in the form x, 0, and z. And so here, what we'll do is we will set y is equal to 0. So if we set y is equal to 0, we can take our equation we have up here, and here we'll have 4 plus 8t is equal to 0. And so here 8t is equal to -4. And so t is equal to -1/2. And so now we can sub these in to our other equations. We get x is equal to -3 plus 3 times 1/2, -1/2. That gives us -3 minus 3/2, which is equal to -4.5. For z, we get z is equal to -5 plus 7 times -1/2. That equals -5 minus 3.5, which is equal to -8.5. And so here we get, therefore, again, that our point of intersection will be at -4.5, 0, and -8.5.